On to simulating data to improve your research part 1.7. And what we're going to do is continue in R, and this time using a script that actually loops through multiple iterations of a simulation. Before we get going though, I suggest you clear your console and your environment. Control L will clear the console and this little broom clears the environment. So if I want to do that, I can do Control L down here, which one down there. And if I want to clear my environment up here, that little broom, you say yes. So you start with a clean slate. That's quite useful because otherwise variables can hang over from previous scripts and it gets quite confusing. You may think you've got something loaded which you haven't, for example. Now this little script is really essentially the same as the previous one, but instead of putting the plots that you generate on your plot thing, plots pane, you get a PDF created with the plots on it. And then you also run the simulation repeatedly automatically. And we're going to compare two different sample sizes, two different values of n. So you have these nested loops. So the first loop repeats twice. So you set a variable I that just runs 2 times. And then you, within each of those, you set a variable j to just do that 10 times. So the first loop, the value in the first loop controls the sample size that you're going to be working with, because you've set up a little vector of possible numbers. And the first value is, I think, 20, and the second is 200, possibly, we shall see, or 100. And it picks one of those two based on the value of I. And the value in the j in the second loop is not used computationally, it's just a counter that ensures that we get 10 repetitions. So we can see that here on the script. Here we go. So the first run through the loop, my n is set to I, which is 1, so it's that value of 20. And then the second time it's my n's 2, which is that value of 100. So this is the power of scripting, is that you can just very easily change aspects of your simulation just by changing one number somewhere. So I've also just made a name for a PDF, which is going to store some plots. You can specify the size of it. This is just a little parameter setting for the PDF, which specifies how many rows and how many columns of figures you want if you've got multiple figures. And then the next bit of the loop is very familiar because it's exactly as we had before with my vector A and B, with my vector B being set to whatever effect size you've specified up here to differentiate the two groups. And then it creates a little data frame as before with score and group, does a t-test. And then what we're doing here is creating something called my stars. If we want to be fancy and put some stars on our plot to denote which comparisons achieve different levels of significance using these rather conventional asterisks. So it defaults to being no stars, and then if you get a p-value less than 0.05, it's 1 star, less than 0.01, 2 stars, less than 0.001, 3 stars. And you'll see that popping up in the plot. Then you just close the plot. So we'll just go run it as far as that. Let me just see if I've got anything else I wanted to. Oh yes, one thing I'd like you to do before we run it. The script is actually set up to simulate the situation where there is a difference between two groups. As I've pointed out up here in the script, we've got my effect size, and that's set to 0.5. So you should be able to change that to simulate the case when there is no true difference, where it's completely null effect. So you need to make one small change to the script before you run it to simulate that null effect. So try that. And then you have to run lines 1 to 45. So in fact, what you need to do here is to change that to a 0. And then we can just run lines 1 to 45, and hopefully it will run. It's going through its loop, it's pausing. This is while it's working through its various iterations. And then when it's finished, you get your little thing back. If ever you get stuck with R, which can happen, you get stuck in a loop that won't end, you can just press escape to escape out of it. So nothing has appeared up here in plots, but you should find that if you look in your folder that you can find things called Pirates 20 and Pirates 100. Open those PDFs. And there we have a PDF with 20 runs of the simulation, each time plotted with a pirate plot. And so yours will again be different from mine. And you can see how common it is to get those that meet conventional statistical significance. Actually, my asterisks haven't quite worked for reasons I'm not quite clear about, because that one is 0.02, should have an asterisk. This one is showing an asterisk. And that's about, you'd expect 1 or 2 just by chance. Well, that one also, yes. My asterisks are probably out of range on this plot because this plot is slightly different from what I did before. But you can do the same again with the Pirates N of 100. And again, you'll see that every now and again one pops up probably that is statistically significant. Just by chance, there's one that's 0.007, there's one that's 0.03, for example. I think we can stop. Actually, I'll just go back to PowerPoint and see what else I had here. Yes, and then this was just an initial 10 runs that I did earlier on. It's showing you exactly the sort of thing you would be seeing on your PDF outputs. Now, if there is no difference between 2 groups, the thing that you need to be aware of is what is the expected value, expected distribution of p-values. If you did 1,000 runs, what would the p-values from all those 1,000 runs look like? I'd like you to have a think about that. What do you anticipate? And then check it out with the simulation by running lines 48 to 66 of this script, which will generate 1,000 simulated data sets and collect the p-value for each run and then plot them in a histogram. And see if your intuition is correct. Most people, or many people, think that if the null hypothesis is true, there'll be lots of high p-values. I want you to check out, is that right? And then we can come back and try the next segment.